Welcome, I am Omotola Fayomi. In the next few minutes, you are going to completely master redox reaction and electrochemistry for JAMB exam. This is consistently one of the most heavily tested topics in JAMB chemistry. Every single year, redox questions appear on oxidation state, electrolysis, calculations, and electrochemical cells. But here is the good news. Once you know the rules, every redox question becomes predictable and straightforward. We are covering oil rig, oxidation states, electrochemical cells, electrolysis, Faraday's laws, corrosion, and balancing redox equation. In these very focused minutes, share this with every student you know who is writing JAMB. Now we begin with the most powerful acronym in all chemistry, oil rig. 4 letters that unlock every single redox question. Oil, that's oxidation is lost. When a species loses electron, it's being oxidized. Its oxidation number increases. Say it with me. Oil, oxidation is lost. What about rig? That's reduction is gain. When a species gains electrons, it is being reduced. Its oxidation number decreases. Say it with me. Rig, reduction is gain. A redox reaction always involves both oxidation and reduction happening at the same time. One species loses electrons, another gains them. You cannot have one without the other. The oxidizing agent is the species that gets reduced. It accepts the electrons. The reducing agent is the species that gets oxidized. It donates electrons. JAMB tests this distinction repeatedly. Say oil rig 10 times right now. Oil rig, oil rig, oil rig. When you see any redox question, this acronym is your first thought always. To use oil rig, you need to be able to assign oxidation state to every element in a compound. Here are the 7 golden rules, and JAMB tests all of them. Rule 1 is that any element in its purest form has oxidation state 0. Sodium metal, oxygen gas, iron metal, all 0. This is the baseline. Rule 2, a simple ionic compound, the oxidation state equals the charge on the ion. Like Na plus is +1, Cl minus is -1, Fe3 plus is +3. Rule 3, hydrogen is nearly always +1, except in metal hydride like NaH or CaH2, where it is -1. Rule 4, oxygen is nearly always -2, except in peroxide like A2O2, where it is -1, and in oxygen difluoride, where it is +2. Rule 5 and 6, the sum of all oxidation states in a neutral compound equals 0. In a polyatomic ion, the sum equals the charge on the ion. Apply this to JAMB's favorite compound, KMNO4. K is +1, O is -2, so +1 plus Mn plus F into bracket -2 equals to 0. +1 plus Mn equal -8 equals 0. Therefore, Mn is equal to +7. And in K2Cr2O7, 2 into bracket +1 plus 2 of Cr, that's chromium, plus 7 into bracket -2 equals to 0. Then 2 plus 2Cr minus 14 equals to 0. Cr equals to +6. Now let us apply oil rig to identify and analyze redox reaction, and this example appears repeatedly in JAMB. Zinc plus copper sulfate gives zinc sulfate plus copper. Let us assign oxidation state to track what changes. Zinc starts as 0 as in free element, ends as +2 in zinc sulfate as ZnCSO4. The oxidation state increased from 0 on the left to +2 by the right. By oil, zinc was oxidized. It lost 2 electrons. Zinc is the reducing agent. Copper starts as +2 in CuCSO4, ends as 0 free metal. The oxidation state decreased from +2 to 0. By rig, copper was reduced. It gained 2 electrons. Copper sulfate is the oxidizing agent in this case. So the half equation shows this beautifully. Oxidation half, zinc gives zinc ion, that's zinc Zn2 plus with +2 electrons, and the reduction half, copper 2 plus 2 electrons gives Cu, that's the copper. Add them together, the electrons cancel, and you get the overall equation. What about the disproportionation? It's a special type of redox. The same element act as both oxidizing and reducing agent in the same reaction. Chlorine reacting with sodium hydroxide gives NaCl. Cl is -1 reduced, and NaOCl, that's the hypochlorite, sodium hypochlorite, Cl minus, Cl there is +1 oxidized. Chlorine goes both ways. The electrochemical series arranges metal and their ions in order of their tendency to be reduced. Understanding this series is essential for predicting redox reaction and calculating cell EMF. At the top of the series are metals with very negative electropotential, like potassium minus 2.93 minus 2.92 volt and sodium minus 2.71 volt. These are the strongest reducing agents. They are most easily oxidized, most willingly to give up electrons. At the bottom are metals with very positive electrode potential, like copper plus 0.34 volt, silver 0.80 volt, and gold 1 point plus 1.50 volt. These are the strongest oxidizing agents. They are most easily reduced, most willing to accept electron. The displacement rule is that a metal higher in the series will displace a metal that is lower from its salt solution. Zinc is above copper, so zinc displaces copper from copper sulfate solution. That blue solution goes colorless and orange copper metal appears. The reverse does not work. Note that copper is below zinc, so copper cannot displace zinc from the zinc sulfate. This is a classic JAMB trick question. Always check relative position in that series. A galvanic voltaic cell converts chemical energy into electrical energy. This is the principle behind battery, and the most famous example for JAMB is the Daniel cell. The Daniel cell has two half cells, a zinc electrode in zinc sulfate solution and copper electrode in copper sulfate solution. These are connected by a salt bridge. At the anode, zinc is oxidized. Zinc gives zinc ions, zinc 2 plus ion plus 2 electrons. The electron flows through the external wire to the cathode. At the cathode, copper ions are reduced. Cu2 plus gains 2 electrons and deposits as solid copper metal. The salt bridge, typically a solution of potassium nitrate in a gel, maintains electrical neutrality in both half cells. Without it, the reaction stops. The cell EMF is calculated as E cell equals to E cathode minus E anode for Daniel cell. That's a plus 0.34 minus 0.76, and that gives you plus 1.10 volt. A positive cell EMF means reaction is spontaneous, and this is the memory aid for electrodes. An ox-red cat. An ox-red cat. Anode is oxidation, reduction is cathode. Say it, an ox-red cat. Crucial difference is that in a galvanic cell, the anode is negative and cathode is positive. Therefore, in an electrolytic cell, this reverses. In an electrolytic cell, this reverses. JAMB tests this distinction. Electrolysis is the reverse of a galvanic cell. Instead of chemistry producing electricity, electricity drives chemistry. This is how we extract metals, plate surfaces, and manufacture industrial chemicals. An electrolyte is an ionic compound that conducts electricity when molten or dissolved in water in aqueous solution. The ions are free to move and carry charge. At the cathode negative electrode, cations, positive ions are attracted and gain electrons. Reduction occurs at cathode. At anode, positive electrode, ions or negative ion or anion are attracted and lose electrons. Oxidation occurs there. For molten sodium chloride at the cathode, sodium ion gain electrons to form sodium metal. At the anode, chloride ion lose electrons to form chlorine gas. In aqueous solution, there is competition between ions at each electrode. At the cathode, the ion lower in the electrochemical series is discharged preferentially, meaning copper ions deposit before hydrogen ions, which deposit before zinc ions and or sodium ions. At the anode, in concentrated halide solutions, halide, chloride ion, bromide ion, and iodide ion are preferentially discharged over hydroxide ion, but in dilute solution, hydroxide from water is preferentially discharged, giving oxygen gas. The electrolysis of brine, concentrated sodium chloride solution, that's what it is one of the most important industrial processes and appears in JAMB repeatedly. It produces 3 valuable products from one electrolysis. At the anode, concentrated chloride ions are preferentially discharged. The equation is 2Cl minus gives Cl2, that's chlorine gas, plus 2 electrons. Chlorine gas is collected at the anode. Its uses are in making PVC plastic, bleach, domestic and industrial, and hydrochloric acid. At the cathode, water molecules are reduced rather than Na plus, that's sodium ion, because Na plus is very high in the electrochemical series. Very difficult to reduce in aqueous solution. And therefore, 2 H2O plus 2 electrons gives hydrogen gas plus hydrogen plus hydroxide ion. And the use of the hydrogen gas is in the production of hydrogen cell, hydrogen fuel, herbal process to make ammonia, hardening vegetable oils to make margarine. In solution, as Cl minus and H plus are removed, Na plus and OH minus remain and form sodium hydroxide, that which is used in soap and paper manufacturing, aluminum extraction and cleaning agents. And this is the industrial chlor-alkali process. 3 word changing chemicals from one single electrolysis. Chlorine and hydrogen are produced in equal volumes. Now let's talk about Faraday's law, which allows us to calculate the mass of substance deposited during electrolysis, and JAMB set calculation question on this topic every year. Faraday's first law is that the mass of substance deposited at the electrode is directly proportional to the quantity of electricity or charge that passed through it. More charge, more mass. That's what it means. Simple. The charge formula is Q equals I times T. Q is the charge in coulombs and I is the current in ampere. Whereas T or time is in second. JAMB biggest trap here is that time must be in second. Always multiply minutes by 60. Faraday's second law. For the same quantity of charge, the masses deposited of different substances are proportional to their equivalent masses. Molar mass divided by valency. The master formula is M equals M times I times T, all divided by N times F. M, that's capital M, is the molar mass, I current, T time in seconds, N the number of electrons transferred, that's valency, and F is the Faraday constant, 96,500 coulomb per mole. Let us work the example. 2 amperes for 30 seconds. True copper sulfate, molar mass of Cu equals to 64. Valency N equals to 2. First, convert time to seconds. That's 30 times 60. That's 1,800 seconds. Q is equal to 2 times 1,800. That's 3,600 coulomb. M is equal to 64 times 64 times 3, 600. Divided by 2 times 96,500. M is equal to 230,400. And divided by 193,000 equals 1.19 grams of copper deposited. Industrial electrolysis application appear in JAMB questions regularly, so knowing each process, its electrode products and conditions is essential. Aluminum extraction is one of the examples, and that's the all en route process. In this case, aluminum ore as bauxite Al2O3 is dissolved in molten cryolite, and sodium aluminum fluoride. Cryolite is the key here. It reduces the melting point from 2050 degrees Celsius all the way down to about 950 degrees, a massive energy saving. At the cathode, aluminum ion gains 3 electrons to form liquid aluminum, which sinks to the bottom of the cell. At the anode, oxide ions lose electron to form oxygen gas, which burns the carbon anode. So, anode must be replaced regularly. This is a key detail JAMB test. Electroplating now. To plate an object with another metal, say silver or nickel, connect the object as the cathode, negative, that's the plating metal as the anode, that's positive. Use the solution of the plating metal salt as the electrolyte. Copper refining, for example, impure copper is made the anode, it dissolves, pure copper is the cathode. So pure copper deposited on it, impurity settles as the anode sludge, which actually contains valuable gold and silver. What of down cell? Extract sodium metal and chlorine gas from molten sodium chloride. Calcium chloride is added to lower the melting point. Sodium forms at the cathode, chlorine gas at the anode. Rusting is one of the most economically costly and environmentally important redox reaction on earth, and JAMB tests it in its context of electrochemistry. Rusting is an electrochemical process that happens when iron acts as both anode and cathode in the presence of water and oxygen. At the iron surface anode, iron atoms lose electrons and becomes iron. Two ion oxidation takes place there. These two ions are further oxidized to iron-free ions at cathode areas on the surface. Dissolved oxygen reacts with water and gain electrons. What about the reduction of oxygen occurs? The resulting iron 3 oxide is hydrated to form rust, which is Fe2O3.xH2O. The rust is porous and so it does not protect the underlying iron. Rusting continues until all iron is consumed. Critical condition: both oxygen and water must be present for rusting to take place. Dry iron does not rust. Deoxygenated water does not cause rusting. Salt water accelerates rusting because it is a better electrolyte. What are the prevention? Painting or oil creates a barrier keeping oxygen and water out of the material. Galvanizing to a solution means coating iron with zinc. Zinc acts as both a barrier and a sacrificial anode. Even if the zinc coating is scratched, the iron is still protected because zinc is higher in the electrochemical series and will preferentially oxidize. What about cathodic protection? And this attaches blocks of, it has to do with the attaching blocks of magnesium or zinc to iron pipeline and ship oils. The magnesium oxidizes preferentially, sacrificing itself to protect iron. And this is why sacrificial anodes are used on ships and underground pipeline. Balancing redox equation using the half equation method is a skill that appears in both theory and calculation questions in JAMB. Master these 5 steps method and you will never be stopped again. Step 1. Write separate half equation for oxidation and reduction. For example here, oxidation have iron 2 plus becomes iron 3 plus 1 electron. Reduction have MnO4 minus, that's manganate iron, plus 8 hydrogen plus 5 electrons gives Mn2 plus 4 water molecules. Step 2, balance the number of electrons in each half equation so they are equal. The oxidation half has 1 electron, the reduction half has 5. Multiply the oxidation half by 5. So step 3 is this: add the two half equations together, the electrons cancel, 5 E minus on each side. You get the final balance equation. MnO4 minus plus 8 plus Fe2 plus, that's 5 of it, gives Mn2 plus 4H2O plus Fe3 plus, that's 5 Fe3 plus. Always check the same atom and the same total charge on both sides. Let's start charge equals minus 1 plus 8 plus 5 into bracket 2 equals plus 17. Right side is plus 2 plus 5 times plus 3 and equals to plus 17. Balanced for oxygen, add water molecules to the side that needs oxygen atom. For hydrogen, add hydrogen ion in acidic form, and that's in acidic solution H plus, or OH minus in alkaline solution. This 5-step process works for every redox equation JAMB can set. Here is your complete redox and electrochemistry cheat code. Every key rule in one consolidated place. Read this before your JAMB exam. Oil rig, which means oxidation is loss, reduction is gain. This is your foundation for everything. Oxidation state: sum equals 0 in neutral compounds equals ion charge in polyatomic ions. Assign known atoms first, then solve algebraically. Cell EMF, that's E cell equals E of cathode minus E of anode. If the answer is positive, the reaction is spontaneous. If negative, not spontaneous. Faraday is equal MIT divided by NF. NF divided by NF. Q equals I times T. Faraday constant is 96,500. Time must be in seconds. This is the most common mistake students make. Brine electrolysis: chlorine at anode, hydrogen at cathode, sodium hydroxide in solution. This is chloralkali process. JAMB biggest trap: the oxidizing agent is reduced, not oxidized. The reducing agent is oxidized, not reduced. Anode and cathode swap the polarity between galvanic and electrolytic cell. Concentrated brine gives chlorine gas at anode, dilute solution gives O2 instead. Now 6 final power tips that cover the most tested detail in JAMB redox and electrochemistry question. 1. Oil rig always increase in oxidation state means oxidized, decrease means reduced. This is your filter for every redox question. 2. The Faraday time trap. If question gives time in minutes, multiply by 60 before substituting into the formula. 30 minutes equals 1,800 seconds. Missing this step loses you every mark in the calculation, and you wouldn't want to do that. 3 is that EMF calculations, E cell, E cathode minus E anode. If you are unsure which is cathode, the half cell with the more positive or less negative electrode potential is always cathode. 4. Anode and cathode polarity switch between galvanic and electrolytic cells. Galvanic anode is negative, cathode positive. Electrolytic anode is positive, cathode is negative. JAMB test this switch. 5. Color changes in redox and visual proof of reaction. KMNO4, for example, goes from purple to colorless. K2Cr2O7 goes from orange to green. Iodine with starch goes from blue-black to colorless when iodine is reduced. These are classic JAMB questions. 6. In copper refining, impure copper is the anode that dissolves into solution. Pure copper is the cathode that grows. The impurity including gold and silver settle as the valuable anode sludge. Color change in redox reaction are powerful visual indicators that JAMB tests regularly or repeatedly. If you know these changes, you gain easy mark. Potassium permanganate KMNO4 in acidic solution is a deep purple violet color when it acts as an oxidizing agent in titration with iron 2 plus or oxalic acid. The Mn7 plus is reduced to Mn2 plus and the color change from purple to colorless. This is the basics of permanganate titration. Potassium dichromate, on the other hand, also K2Cr2O7 is orange. When it oxidizes organic compounds or iron 2 plus, the Cr6 plus is reduced to Cr3 plus, changing color from orange to green. And this is used as the basis of breath analyzer test for alcohol. Iodine with starch solution gives a characteristic blue-black color. When iodine is reduced to iodide, the solution or the color changes to give a colorless solution. This is the basis of iodometry titration. Memorize this: purple to colorless, orange to green, blue-black to colorless. Say them out loud right now. Outstanding! You have just completed this masterclass in a few minutes in redox reactions and electrochemistry, covering every concept that JAMB has ever tested on this topic. You now know oil rig and how to assign oxidation state, how to identify reducing and oxidizing agent, how the electrochemical series predicts reactions, how galvanic cell work, how to calculate EMF, how electrolysis works, and which ion is discharged first. Faraday's law, what about that, with full calculation, the chlor-alkali process, the aluminum extraction, copper refining, electroplating, corrosion and prevention, how to balance redox equation with half equation, and color changes for KMNO4, K2Cr2O7, and iodine starch. That is a complete JAMB redox syllabus. If this particular minute helped you today, and I know it did, please like this video, share it with every chemistry student you know who is writing this exam, and subscribe to this channel for more rapid revision workflow on different chemistry topics. Comment below which section was most helpful. Is it already your Faraday's law, the brine electrolysis? Let me know and tell me which topic you want us to cover. Remember, you are not born to just pass JAMB. You are born to excel in chemistry, in career, in your faith, in your life, and that is why we are here on this perfect platform. And we are here for your holistic excellence for the whole person. God bless you abundantly. Go and get that grade. I will see you in the next rapid revision video. More cheers.